This lesson is going to show us how to understand significant figures. It'll be a much easier way perhaps than what you've heard before. We have the typical way to count, which talks about all non-zero digits being significant and zeros between non-significant ones could be, could not be. It's just confusing. So let's go to a much better way of understanding significant figures. First of all, we're going to follow a few simple rules. When we start counting, we will start counting with the first non-zero digit. We will never start counting with a zero. The second thing is, once we start counting, we will count everything, regardless if it's a zero or not. And then the direction we count is set up this way. If there's no decimal point, then we're going to count from the right to the left. If there is a decimal point, we're going to count from the left to the right. So here we go. Let's try this. For our number 1.234, we do have a decimal, so we're going to follow this rule down here. If there is a decimal, we'll go from the left to the right, and we're going to start counting with the first non-zero digit we see. So right away we have 1, 2, 3, 4. So our number of significant figures is 4. On this next example, we have a decimal point also. So I'm going to count from left to right. So we have 1, 2, 3, 4. Once we start counting, we keep counting everything. All right, let's mix it up a little bit. On this problem, we do not have a decimal point, so we're going to go from right to left. And in going from right to left, we do not start with the zero, we start with the first non-zero. So as I move across, this 5 will be the very first number that I include. So it'll be 1, 2, 3, 4. So once we start counting, we count everything from then on. The next one, we do have a decimal point, so we're going to go from left to right, but we're going to start with the first non-zero. So we're going to skip past these zeros, start with this 2, so we're going to count 1, 2, 3. And once we start counting, we keep counting, so we do include this 0 over here. So this one will have 3 significant figures. Our next example, it has a decimal point, so we'll count from left to right. Once we start counting, we keep counting. 1, 2, 3, 4, 5, 6, 7, 8. So we count all of those digits once we start counting with a non-zero. Okay. The next couple of examples here are going to show us how to distinguish how to write numbers and interpret them. So we have no decimal point here. So we'll move from right to left, starting with the first non-zero. So we're not going to use this 0, we're not going to include this 0, but we will use this number 4. So that way of representing the number 400 has one significant figure. This next way, it has a decimal point, so we're actually going to read it from left to right. 1, 2, 3. So that will be 3 significant figures. Our next example, we have 4.00 times 10 to the second. This is a more traditional way, I would say, of writing it with scientific notation. So this is an easier way to understand, emphasizing the fact that we actually have 1, 2, 3 significant figures. It's the same number of 400 that we have right above it, but it just kind of shows a different way of expressing it. So the question is, I can write 400 with 1 significant figure or 3 significant figures. How do I get 2? Well, we would rely on scientific notation then. I do have a decimal point, so as we move across from left to right, we'll have 1, 2. It's still the number 400. Our tens place in the number 400 is significant. Our ones place is not significant. So this one only has 2 significant figures. Let me mention for just a second about why we do significant figures. This number 400 is basically saying we know that we have 400 or so. It's kind of a range of values. We're not pinning it down to 407. We're just saying it's around 400. A good example of this might be if we're counting eggs, we might say that we have 43 eggs. Okay, and we would be counting those numbers of eggs. A distinction with that would be if we were measuring the length of an egg, we might say that we have 4.3 centimeters long for an egg. And by that, we're representing the measurement of it. And this is whenever significant figures greatly come into play. We want to say that the tenths place, that 4.3 centimeters, that tenths place is actually a value that we can distinguish. And our measuring tool could distinguish what a tenth of a centimeter was. if I took a meter stick and I measured the length of an egg and I said it was 4.352681 centimeters, that would be preposterous because I can't fine tune enough to show the significance of the last several digits that I just rattled off. So it really has a lot to do with a measuring instrument. Okay, let's talk about adding and multiplying. When we add significant figures, we just go ahead and add them as we see them. And then what we're going to do is we're going to use the fewest number of decimal places represented. So in a sense here, whenever we add these, we have our tenths place. And so we're going to have our tenths place recorded as our last significant value that we're going to record. And so we're actually not going to use that 8.434. We'll round it appropriately and say that it is 8.4. Multiplying, on the other hand, we're going to use the fewest number of significance digits presented. So not off decimal places, but how many significant digits we have. We have 5 in our first number, 2 in our second. So after we multiply, we're going to represent this with only 2 significant figures. So we're going to have the 3 and the 6. So our number here will be 3.6. If you enjoyed this, you can find other videos at Math and Stuff or my Weebly channel. Thanks a lot.